Alright, thanks for watching, and let's do a good old-fashioned line integral. So let's calculate the line integral of the function x squared plus y squared, where c is literally a line going from 1, 0 to 4, 1. And what does that mean? Think of it, for instance, in terms of physics. If you have some wire that's just a line segment with density x squared plus y squared, what is the total mass of that wire? And the nice thing is we can just calculate it using the usual method, picture, if you want parameterization in math. So let's just draw a quick picture of this. So you have the line 1, 0, connecting it to 4, 1. Okay, not drawn to scale, which just becomes this. And then let's just parameterize this. So the whole point is a line integral is a one-dimensional integral, so it should be expressed as a single variable integral, which we'll do here. So let's parameterize c. So let's figure out what x of t is and what y of t is. So you see, the whole point is this line, we can parameterize them with x and y, but where t, if you want, is with respect to time. And the way you do this is with this on and off switch. So you put your point 1, 0 here and the point 4, 1 here. And the question is, do you put 1 minus t or do you put t here? Well, what you want at t equals 0, this should start at 1, 0, so you don't want to kill this. The problem is, if you put t here, then at 0, those two things would disappear. That's why you have to put 1 minus t. On the other hand, at 0, you want this to disappear, so you have to put t. And in fact, you can check if t becomes is 0, this does become 1, 0. If t is 1, it becomes 4, 1, which is precisely what you want. And this you can simplify. 4t minus 3t becomes 3t, and then plus 1. And here, t is just t. Which, if you'd like, makes sense. In other words, if you start at 0, the altitude should go from 0 to 1. That's why it's t. But if you start from x, well, it should go from 1 to 4, some sense with a slope of 3. So that's completely fine. Or in other words, the direction vector of this line is 3, 1. So indeed, this is 3, 1 times t, and you're starting at 1, 0. So we have that. And again, t in this case is between 0 and 1. Okay, then we just need to evaluate that line integral. Integral over c of x squared plus y squared ds. Then what this becomes, integral over a new parameter from 0 to 1 of x becomes x of t squared plus y of t squared. And then ds, you should just think of it as square root of dx squared plus dy squared. In other words, if you have a triangle with sides dx and dy, ds is precisely the diagonal of this triangle, so you just use the Pythagorean theorem and the chain rule to get that this is square root of x prime of t squared plus y prime of t squared, and then times dt. I hope people can see this, but again, we get xt squared plus yt squared times square root of x prime squared plus y prime squared. Okay, and then you just have to plug in our formulas for x and t. So it's the integral from 0 to 1 of 3t plus 1 squared plus y squared, which is t squared, times square root of x prime squared. So the derivative of x with respect to t is 3, so 3 squared. The derivative of y with respect to t is 1, so 1 squared dt. Which you see, it's nice, now it becomes a constant. So what this is, it's square root of 10. So what we get is square root of 10 times the integral of this thing. Well, it's just a one-dimensional integral, so in this case you just expand it out, for instance. So 9t squared plus, so 2 times 3 times 1, so 6t plus 1 plus t squared dt. And what this becomes, it's square root of 10 integral from 0 to 1 of 10t squared plus 6t plus 1 dt. Calculate that to be square root of 10. So let's see, 10t cubed over 3 plus 6t squared over 2. So I think 3t squared and then plus t from 0 to 1. And the nice thing is all the terms are 0 or just 0. So what you have, it's square root of 10 times 10 thirds plus 3 plus 1. Okay, let's see. So square root of 10. Let's see. 10 thirds plus 4. 4 becomes 12 thirds. So I think square root of 10 times 22 thirds. Let me just double check. Yes, I think that is the answer. So, in other words, the mass of the wire in this case, it's square root of 10 times 22 thirds. Alright, I hope you like this little exercise. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.